What if, right now, a black hole was creeping towards Earth, ready to tear our world apart? This isn't just science fiction. It's a real possibility that's far more terrifying than you might think. Black holes are not just ideas from movies. They are out there, hiding in the vastness of space, waiting for the right conditions to unleash their unimaginable power. There are millions of these mysterious objects scattered across the universe, each one a potential threat to anything that gets too close. And if, by some unimaginable accident, we were to create one near Earth, the consequences would be catastrophic. Picture the incredible force, the unimaginable power, that would pull our planet apart piece by piece. In such a scenario, you'd better hold on tight because things would get unbelievably intense, literally tearing apart the very fabric of our world. What could happen if Earth got pulled into a black hole? So, what exactly would happen if Earth got caught in the gravitational pull of a black hole? Could we somehow maintain our orbit around the Sun while also being drawn toward a black hole? And perhaps the most frightening question of all, would we survive the process known as spaghettification, where everything is stretched out into thin, noodle-like strands? Let's dive deep into these questions and explore what would happen if Earth were ever sucked into a black hole. The proximity of black holes. First off, did you know that there's a black hole just 3,000 light-years away from us? Yes, that's right, a black hole that is actually visible to the naked eye. Luckily, we are currently at a safe distance from this stellar black hole, as well as many others like it. In fact, our galaxy, the Milky Way, is home to an estimated 100 million black holes that we know of. These black holes are the leftovers of stars that once shone brightly before meeting their explosive end. When a star that is 10 to 20 times larger than our Sun explodes in a supernova, it can collapse in on itself, leaving behind a stellar black hole. Stellar versus supermassive black holes. Stellar black holes are relatively common and usually have a diameter of about 16 kilometers. But not all black holes are the same. In the universe, there exist even more massive versions known as supermassive black holes. These cosmic giants are on an entirely different scale, with diameters that can span the entire size of our solar system and masses that exceed 1 million suns combined. One of these supermassive black holes, known as Sagittarius A, is located right at the center of our galaxy, holding the Milky Way together with its immense gravity. The sheer size and power of these black holes are almost impossible to imagine. How close is too close? Now, just how close would a black hole need to be to pose a serious threat to Earth? Surprisingly, even a black hole no larger than a pinhead could destroy our planet if it were close enough. This is because black holes are incredibly dense, packing an enormous amount of mass into a very small space. This mass creates such a strong gravitational pull that not even light can escape. Our survival would depend entirely on whether we had crossed the event horizon, the so-called point of no return surrounding the black hole. Once something crosses this invisible boundary, it would need to travel faster than the speed of light to escape. But nothing can outrun light, so anything crossing the event horizon is doomed to be sucked into the black hole. What happens if Earth gets too close? If Earth were to get dangerously close to a black hole, the side facing the black hole would begin to stretch and warp under the immense gravitational force. Our atmosphere would be the first to go, getting sucked away into the void, followed by massive chunks of the Earth itself. If, by some chance, Earth managed to fall into orbit around the black hole instead of being pulled directly in, we would face another terrifying phenomenon called tidal heating. The intense and uneven gravitational pull would cause the Earth to deform constantly, generating massive internal friction. This friction would heat the Earth's core to disastrous levels, leading to violent earthquakes, erupting volcanoes, and enormous tsunamis. It would be a cataclysmic chain reaction, the trifecta of doom. The horrors of spaghettification. Eventually, as Earth continued to draw closer, it would begin to stretch and elongate in a process known as spaghettification. This isn't just a colorful metaphor. It's a real and terrifying consequence of extreme gravitational forces. Imagine you're a superhero and you decide to take on the black hole headfirst. As you approach, your arms, being closer to the black hole than your feet, would start to stretch out, pulling your body into a long, thin shape. You would become more and more compressed as you got closer. In a typical stellar black hole, spaghettification could occur several hundred kilometers away from the event horizon. But if you were dealing with a supermassive black hole, this gruesome process might happen inside the event horizon due to the black hole's immense size and power. Ultimately, anything that gets too close to a black hole, whether it's a person, a planet, or even a star, would be ripped apart into individual atoms. The impact on our solar system. But the destruction wouldn't stop with Earth. If our entire solar system were sucked into a black hole, the delicate balance that keeps our planets in orbit around the sun would be shattered. The planets could be sent crashing into one another in a chaotic and catastrophic collision. And if that wasn't bad enough, our asteroid belt, comprising over 552,894 known asteroids, would also get pulled in. Among these, about 200 asteroids are more than 100 kilometers across. A collision with just one of these massive space rocks would spell the end for us, long before Earth even got a chance to become cosmic spaghetti. Radiation, a final blow. As all the matter in our solar system spirals into the black hole, it would form what is known as an accretion disk. This is a swirling mass of matter that orbits the black hole before finally being sucked in. As this matter gets closer to the black hole, it releases massive amounts of radiation. Even if we somehow manage to avoid the asteroids and the gravitational forces, this radiation would be more than enough to finish us off. The intense radiation would fry any remaining life on Earth, making survival impossible. Rare circumbinary planets and orbiting a black hole. Interestingly, astronomers have discovered rare planets known as circumbinary planets that orbit not just one, but two stars. This raises an intriguing question. Could Earth orbit both the Sun and a black hole simultaneously? While this might be a theoretical possibility, the extreme tidal forces exerted by the black hole would likely make Earth uninhabitable. Worse still, we might get ejected from our orbit entirely or, even more disastrously, get swallowed up by either the Sun or the black hole. Unfortunately, there doesn't seem to be any scenario where Earth comes out on top. Could we survive in a space shuttle? But what if, just maybe, we could protect ourselves in some sort of hyper-reinforced space shuttle? If we somehow managed to survive the journey past the event horizon, we would find ourselves in a realm where the laws of physics as we know them no longer apply. Gravity, the speed of light, even the way atoms bind together, everything could be completely different. The truth is, we simply don't know what would happen inside a black hole because we can't get any information out of one. It's possible that we could be pulled into another dimension, end up in a parallel universe, or experience something even stranger that we can't yet imagine. In fact, some scientists speculate that we might already be inside a black hole, with our entire universe existing within its boundaries. But that's a story for another time.